What do I even call this thing? It's either a really big mini PC or a not so mini regular PC. Either way, this is the GTR9 Pro from V-Link, which comes loaded with a 16-core AMD Ryzen AI Max Plus 395, 120 gigs of RAM, kinda, 2 terabytes of NVMe, and 10 gigabit networking, all for the price of $2,000. Wait, $2,000? What the f***? Okay, yeah, wow, this is an expensive machine, but I mean, $2,000 is not an astronomical price for a computer as long as that performance and the features can back that price up. So, does it? Well, nah. All right, let's start with the spec sheet here. We got the fancy Ryzen AI Electric Boogaloo chip, which does include both integrated Radeon 8060S graphics and 120 gigabytes of soldered DDR5 ECC RAM. Yep, it's soldered RAM, which pros, it's hella fast and lets you share that RAM with the GPU, but cons, you can't upgrade or replace it. We also get a 2 terabyte PCIe Gen 4 NVMe drive and another vacant slot for expansion. As for I/O, we have a solid selection here. An SD card slot, 3 10 gig USB and 2 USB 4 40 gig ports, 2 3.5mm audio jacks for some reason, HDMI 2.1, DisplayPort 2.1, and dual 10 gig RJ45 ports. Oh, and Wi-Fi 7 if you're about that life. So I mean, yeah, really good I/O between the USB 4 and the dual 10 gig ports, but I'm kinda annoyed we don't get Oculink. V-Link has put Oculink ports and other PCIe expansion options on their other PCs, but decided to exclude it from their top-of-the-line, holy shit, giant mini PC package. I don't know if it's a hardware compatibility thing or what, but it's kind of a bummer. Other cool things we do get, though, are a fingerprint reader on the power button, built-in microphones that are powered by an advanced AI chip, built-in speakers, which I actually kind of like, and an integrated power supply, so no big old power brick. And I feel like people are kind of split right down the middle on that last one. And I really don't think any of these features alone is worth $2,000, but when you add up all those little things, I still don't think it's $2,000, but they are nice features. You know what, let's try this. Hold on. Okay, I don't know. You tell me, are these microphones worth it? I legitimately don't know because I haven't listened to this back yet, but what you get. And build quality here is actually really solid. You may have picked up that this thing shares a striking resemblance to the Mac Studio, and it's even a similar size. Fortunately, the build quality is also up there with the Mac as well. The clean unibody metal chassis and minimalist design lend itself to the high quality aesthetic Apple is famous for. And similar to most Apple machines, this thing is quiet, like super quiet. It's been on this whole video, I legitimately can barely hear it. And there are 2 fans in here, and even at full blast, it's barely noticeable. Internally, there really isn't much to see here. Removing the screw covers and 4 screws gives you access to some ribbon cables, and under the heatsink, you'll see your 2 M.2 NVMe slots. If you wanted to get to the fans and the other side of the motherboard, it looks like there are quite a few screws and components that you would need to remove, but realistically, the storage is the only thing you can change. It is nice to see 2 4X slots, which leads me to believe that you can get full speed out of both of those drives. Alrighty, everything I said up to this point could mean nothing if all you care about is performance, so let's talk about that. Now we've got a pretty beefy 16-core 32-thread CPU in here, and to the surprise of nobody, we got a high Cinebench 2024 multi-core score of 1836, which puts it in line with Apple's M4 Max, Intel's 14700, and the desktop class Ryzen 9900X. So we're talking about a high-end chip here. And to my surprise, the max temps we saw during these runs was only 73 degrees. And to be fair, fans really didn't get all that loud. Like I mentioned, super quiet. Single core in Cinebench was 114, which has it up against the mid-level Intel desktop chips from a generation or 2 ago. Overall, yeah, would I like to see better? Sure, but the package you're paying for here isn't just raw Cinebench numbers. This system is designed to be power efficient with a super capable CPU, high-end integrated graphics, and soldered shared RAM. If we're talking about raw GPU performance, a good way to check is from gaming benchmarks. While yes, you could definitely play AAA titles on this thing, I don't know that anyone is buying this specifically for gaming. Anyway, I ran a few Cyberpunk benchmarks at 1440p high settings, with some really good results. With AMD FSR set to auto and ray tracing turned on, we got a playable 37 FPS. If you're like me and don't care about ray tracing, then you can turn that off, set FSR to balance, and you get 95 FPS. Then for you purists who like to pretend that you can tell if FSR is on and consider that cheating, with no FSR and no ray tracing, we get 62 FPS. So yeah, I get that not everyone cares about gaming for a device like this, but it's certainly a good way to test the capability of the hardware. You're most likely getting this thing to use as an actual workstation for content creation or even AI. I downloaded Ollama, which is probably the easiest way to get going with local LLMs, and since we have 128 gigabytes of shared memory, we should be able to run some big old models. I started off with something smaller, the Gemma 3 12B, which gave us a response rate around 23.5 tokens per second. For comparison, my AI server with multiple RTX 4000s with the same model got 34 tokens per second. If we're talking price for performance here, this thing is way better than my AI system considering what that costs. But then I stepped up to a larger model with the Qwen 3 30B, and for some reason that was faster. Look, I'm not going to pretend to understand the nuances of AI, so I'm guessing this model might just be better optimized or something, but we were getting 44 tokens per second. And my AI server got 84 tokens per second. So actually half the performance this time around. Next, I wanted to jump into a real big boy and use the GPT OSS 120B model. However, when trying to run it, I was getting an error that I only had 44 gigabytes of available RAM, so it wouldn't work, which is strange. I went to check my RAM and noticed that Windows was only allocating 32 gigabytes for use, with around 90 going to the dedicated hardware, which I assume was a GPU. My guess is that Ollama on Windows isn't used to working with shared memory like this, so maybe it was having some trouble, but then I went to the Beelink product page and noticed that they only advertised up to a 70B model, which uses around 48 gigabytes of VRAM. So what's the point of the 128 gigabytes and 96 gigabyte numbers if we're maxed out at 48 gigabyte AI models and 32 gigabytes in Windows? I'm legitimately asking, I really don't know. Now I can already hear you guys typing away, Brett, but it's on Windows, and we all know Windows sucks, so you should just use Linux and probably work fantastic on there. Okay, yeah, I put Linux on here and it did the exact same thing, so sorry. I even went into the BIOS to find the setting for the GPU memory allocation, and you only have the option to toggle between 96 and 64 gigabytes allocated. I'm sure this is just a lack of understanding on my part to how Ollama or any AI models interfaced with the GPU, so just blame me if you really want to. As for content creation, this is more of my wheelhouse since I am a cringy YouTuber. My software of choice is DaVinci Resolve, and my codecs of choice are ProRes and H.264. I loaded up a project with a healthy mix of both to see how it handled real-time editing and more measurably, is that a word? More measurably how quickly it can render a project. I should note that we do get dedicated encoders and decoders on the big three, H.264, H.265, and AV1. Apple is the only one who does dedicated ProRes transcoders, I think, and for the most part, ProRes is an easy codec to edit, so it's really not a huge deal. I will say the editing performance was pretty smooth and certainly usable on my 4K timeline with native footage, no proxies. And for rendering time, I can't really complain. This roughly 11.5 minute video rendered in about 10 minutes, so just under real time. This video was a combination of 4K H.264, ProRes, and large image files, so about average for a YouTuber. For reference, my 24-core Threadripper 9960 with an RTX 5090 system rendered that same video in about a minute and a half. But just the GPU on that system costs as much as this entire PC. But to be fair, while that system may have been 3 times the price, we are getting more than 3 times the performance in a real-life measurable test. This isn't theoretical, this isn't a benchmark, this is how I actually use my workstation. Now, does that mean the Beelink is bad? Absolutely not. Most people editing in 4K H.264 would probably be making proxies to make their editing smoother, and for a rendering time of less than the video length, that's pretty decent. But you're not really paying for decent here, are you? Okay, so overall thoughts here. I'm conflicted. On one hand, it's a great piece of hardware with awesome performance in AI, especially. But for $2,000 with no real upgrade path, I mean, I don't know. You could argue that it would be a great virtualization server with its 16 cores and power efficiency and high-speed I/O, but you could just build something similar for half the price. I mean, maybe if they added Oculink for PCIe expansion, that would help. I don't know. And as a workstation, it's the same story. It's going to perform great and it's going to look nice on your desk and you'll most likely be very happy with it, but you'll just have less money in your pocket than necessary. I think the optimal buyer for this is someone who's looking for a workstation but also wants to run local AI models and wants it in a small-ish, power-efficient form factor. And I think that's a pretty niche audience, right? I don't know, maybe I'm off base there and maybe there's a larger market than I think, but for $2,000 you could just get a pre-built from Micro Center or something and have room for expansion, hard drives, and upgradability. But then again, what does a Mac Studio cost? But then again, what kind of performance do you get on a Mac Studio? This is difficult, man. Just vote with your wallet. I don't know. Do you agree? Disagree? Sound off in the comments. But that's all I have for this one. If you liked it, then drop a like and subscribe for more hardware reviews, I guess. I want to give a huge shout out to my YouTube members and my Patreons. You guys are my big mini PC server thing with all the I/O, all the expansion, and like half the price of this thing. Y'all are the best. And if you're still watching, your Windows hello. Thank you so much, and I'll see you in the next one.